2 of Chapter P. I know, Chapter P, the prologue, but, whatever. Section 2 is another short one. It's most definitely review of a lot of stuff that you've seen. There may be a new little thing here or there, but for the most part, this should be review. So this is on the Cartesian coordinate system. You might be thinking the Cartesian coordinate system, what is that? That's just the regular graphing XY plane that we use. It's called the Cartesian coordinate system. It's named after Rene Descartes, who most people think, oh, he was a philosopher. He was also a mathematician. Our learning targets for the day: you can plot points on a coordinate plane. You can evaluate and simplify expressions involving absolute value. That is something that people do have trouble with from time to time. You can find the distance between two values on a number line or 2 points on a plane. You can find the midpoint between two values in a number line or 2 points on a plane. So we have distance formula, we have midpoint formula. And you can draw a scatter plot to show data. Honestly, this first one and this last one are essentially the same thing, because a scatter plot is just a whole bunch of individual points plotted on the plane. So those two are the same for all intents and purposes. So the Cartesian plane, what is that? I had mentioned that it's just a normal plane. We have our x-axis, we have our y-axis. If we wanted to plot something, let's say we plot the point 2, 1. We just go over 2, up 1, and we plot a point. It's what you've been doing forever with those. Fun fact, the x part of it is called the ordinate, and the y part of it is called the abscissa. That's not important at all, really, but it's fun if you're ever on Jeopardy and they ask you that's the answer. I expect some of the winnings. So, absolute value. What is absolute value? Absolute value is just the distance a number is from 0. Now, I know in the book it says that's the absolute value of a real number. Well, we know that there's also imaginary numbers. The absolute value is still the distance from 0. Finding it's a little bit different. For a real number, it's just you make it positive. That's all it is. The absolute value of, say, 3 equals 3 because it's 3 away from 0. The absolute value of -3 is also 3 because it's 3 away from 0. So that's all absolute value is. The distance between numbers, let me erase one of these. I didn't have quite enough room there. So the distance between numbers. This isn't the distance between points. This is the distance between numbers. Like, how far is it from x equals 1 and x equals -9? To do this, you just subtract -9 minus 1. And then take the absolute value because it's a distance, so it'll be positive. -9 minus 1 is -10. Absolute value is 10. So it's 10 units from -9 to 1, or from 1 to -9. It does not matter which direction you're going. Same thing if you had the distance from 5 to 7. It's just 7 minus 5 is 2. The distance is 2. You could have gone 5 minus 7 is -2. Absolute value, you still have 2. So distance between numbers, all you're doing is subtracting them and then finding the absolute value. The distance between points. This one is a little bit tougher because it's not a straight line, so it uses the distance formula, which, if you remember, looks a lot like that. It's the x point minus the x point squared plus the y point minus the y point squared, and then the square root of that whole thing. So if we have 2 points, let's say we have the point 3, 7 and the point 5, 2, the distance between them is going to be square root. We're going to have x minus x, so that's 5 and 3. We'll go 3 minus 5 squared, plus, then y minus y, that's 7 and 2, go 7 minus 2 squared. I know that in slope, it's super important to keep the order the same because that changes the sign. In this case, we're going to instantly square it, and so it's going to end up being positive anyway. So even if you switch the order around, that's not going to change your answer at all. But we did actually keep it in the same order. So our distance, we're going to have square root. 3 minus 5 is negative 2. Squared is 4. Plus 7 minus 2 is 5. Squared is 25. So our distance equals the square root of 29. And that's what it is. You could simplify it. Square root of 29 is not going to reduce. I wouldn't make it a decimal unless it asks for an approximation. But that's the distance formula. It's, again, something you've been working with for a few years now, but something that can sometimes be forgotten. Midpoint. What's the midpoint between two numbers? The midpoint between two numbers, you just find the average. You add the two numbers together and divide by 2. So the midpoint between A and B is A plus B over 2. So the midpoint between negative 9 and 1, we go negative 9 plus 1 over 2. Negative 9 plus 1 is negative 8 over 2, which is negative 4. Negative 4 is exactly in between negative 9 and 1. It's 5 away from 1, and it's 5 away from negative 9. So that's the midpoint between two numbers. A midpoint of a line segment, you do the same thing with the x parts and with the y parts. So if we were using the same point that we started out with, the 3, 7 and 5, 2, the midpoint is going to be 3 plus 5 over 2, comma 7 plus 2 over 2. We just add the x's divided by 2, add the y's divided by 2. It's a point, it stays a point. 3 plus 5 is 8, divided by 2 is 4. 7 plus 2 is 9, divided by 2 is 9 halves. Yeah, you could go 4.5 or 4.5 if you want to, but 9 halves is also perfectly fine. In fact, a lot of times when we end up with improper fractions, we're going to still need to be using it, and they're best used in improper form. So leaving them improper is fine. I don't like the word improper because it makes it sound like it's not supposed to happen when it's okay. So that was the Cartesian plane. Again, stuff that you know brings us to circles. You might think, wow, that's a big jump from the Cartesian plane to circles. Well, not actually so much, because a circle is defined as all points that are equidistant or the same distance away from a center point. And so we start out with the distance formula, because that distance is going to be the same. All right, so a couple things that we have to do here. One, the center point, the point that we are always focusing on, like that's going to be part of the distance to all of them. We're going to give that a name. Let's call the center h, k. Why do we use the h and k? Not entirely sure, but it is a fairly standard thing for the center. So we're going to call the center h, k. And then the other point, we'll make that the point 2. So that's x2, y2. And then the other point that we're going to measure is going to be a bunch of points. It's going to be all the points. So instead of a specific x1, y1, we're going to make just x and y. So this is point 2. Point 1 x1, y1 is just going to be x comma y to make them variables as opposed to a specific point, and we're going to plug those in. So our distance is now equal to the square root of x minus h squared plus y minus k squared, which is all fine and dandy, except that we don't want to have a big square root sign. That kind of muddles up the problem a little bit. So let's square both sides. So instead of d equals, let's have d squared equals, then we have no root, x minus h squared plus y minus k squared. All right, so the distance from the center to any point where it's constant, we're going to get all the x's and the y's there. Now we usually have a name for that distance from the center of a circle to the edge. We call it a radius. So as opposed to using d, we could use r for the radius for that distance, and we end up with the equation of a circle. X minus h squared plus y minus k squared equals r squared. It comes directly from the distance formula. It's exactly what it is. So what are you going to be doing with this? You're not going to actually have to derive the equation for a circle, but it's going to tell you to find an equation of a circle centered at, let's go 5, -3, with a radius of 2. And we write the equation. Well, that's h and k, so x minus 5 squared plus y minus negative or plus 3. Notice the minus signs are part of the equation. Squared equals 2 squared. You could make that 4 if you wanted to. You can leave it as 2 squared. Doesn't really make much of a difference. So that's a center and a point. Maybe you have endpoints of a diameter. So you can use the distance formula to find the distance. You can use the midpoint formula to figure out what the center is. And you're back to exactly what we had. You'd have to divide the distance of the diameter by 2. Perhaps it gives you an equation as you find the center and the radius. Perhaps our equation is x squared plus y plus 2 squared equals 7. What is the center? What is the radius? So the center, we have x squared, there's nothing there. Exactly, 0, comma, y plus 2 makes it -2 is the center. And the radius, well, the radius squared equals 7, so we have square root of 7. And we don't have to worry about plus or minus because the radius is a distance, so it will be positive. So